Start recording. There we go. Right, Little Man Computer. A program written in assembly language. The thing that translates that for us to machine code is called an assembler. It assembles assembly language. An assembler. Right, it doesn't work correctly. Now, this was an interesting question because a lot of people didn't answer it properly. It gave us some numbers. If they give you some numbers, they want that used in the answer. Right, so this program compares the two numbers they've inputted, but it outputs the smallest. That's not what it was supposed to do, but that's what it does. So, it said, what does the program do? It didn't say, tell me what all the instructions in a Little Man Computer do. It says, what does this program do? So, it takes two numbers, compares them, and outputs the smallest. Compares, outputs the smallest. That's what it does. Compares, outputs, smallest. Right. They gave us the data. So, in this case, 4 is outputted. Right. And then the next bit, the fix. When they say explain in a program, they want you really to put some code. So in Little Man Computer, the fix, there's actually a trivial fix. And it does say in the mark scheme that they're quite happy if you annotate the program. So where we do the comparison here, if we just switch the values, so switch that for num B and switch this one for num A, that'll fix the program and it'll work. That's the, you could rewrite it, but no, it's easier just to switch the two values that you load up. Quite a few people did say that. Quite a few people did waffle a bit on that one. But that's all you had to do. That was the fix to the program. Okay, the next bit. Right, you all did pretty good on this, but don't overcomplicate it and don't start doing weird physics notation either. Okay, because that will get you in a whole world of trouble. Okay, right. So they just wanted a program that inputs two numbers, compares them, outputs the biggest. Okay, so let's just do that. So A equals input, B equals input. You only got one mark for that. A mark for doing a comparison. Keep it simple. If we're going to compare, you don't have to literally implement Little Man Computer. We can just say if A is less than B, print B, because we want the biggest, else print A. That was it. Okay? You don't have to make it complicated. Some people did subtract them and say if it was less than 0, so they're like mimicking Little Man Computer, which is not wrong. You're just giving yourself more scope to screw it up. Alright, so try and reduce the screw up potential. Right, the next question. Quite a lot of good answers on this one. A few people were a bit off on this. Right, instructions that alter the PC. The only instructions that can alter the PC are the ones that change the standard increment, which are our branch instructions. So our branch instructions are branch always, branch plus, and branch Z, but they said in our program. So let's have a look back at our program. Which ones do we have in there? We got branch plus and branch always. So if you put branch Z, I don't think anyone did, then you wouldn't have got the mark because it wasn't in there. So that's not in the program. They changed the program counter. They, instead of it being linear, they say, oh, go off and do it somewhere else. Right, and in order to fetch data, we're talking about the first step of the fetch execute cycle. We copy the program counter to the memory address register. That's the selector. If we want to read from memory or write from memory, we'll always put the address in the memory address register. That's its purpose in life. To be used as a holding point to transport along the address bus to the memory controller. I think that was the end of that one. Right, stop that one.